Hello and welcome back to another episode of Math with Sohn. Today we are going to be finding the inverse of quadratics. So let's get into it. I got the first one here. This one's relatively easy, but if you have to find your inverse, the first step every single time is to switch your x and your y. So x would equal y squared minus 4. And then from here, your job is to solve for y again. So we're going to add 4 over to the other side. That would make x plus 4 is equal to y squared. And then from here, you would have to square root. Now, this is the first time in like forever that when you're square rooting, you do not necessarily want to write plus or minus and call it a day. Because of the vertical line test, we can only have one of these two answers. So technically, it's a positive or a negative. And the key there is the word or. So your inverse is actually the square root of x plus 4 or the negative square root of x plus 4. And you'll find that a lot of times the textbook is just going to put the positive one for the inverse because they don't want to be too picky. Okay, but it cannot be both. It can either be one or the other because otherwise, if you were to graph it, it would be like a sideways parabola. That would have been to the left by 4. And it would fail the vertical line test, which we have a different video out showing that if it fails that vertical line test, it's no good. All right, so that's the first one. The next one is going to be much harder. This one's going to be y equals x squared. We'll go with minus 4x plus 1. Okay, if you have to find the inverse of this, you cannot just switch your x and y and be happy. Because as soon as you switch your x and y this time, you get x equals y squared minus 4y plus 1, which won't work because now how do you solve for y? Okay, and the way that you get y by itself in this problem is actually by finding the vertex. So for your vertex, you have two options. You can do negative b over 2a, get your answer, and then plug it back in, which in this case I guess would be solving for y. Or you can use completing the square, okay? So I'm going to do completing the square first because it is much quicker and easier, and then I'll do the negative b over 2a if you've never seen completing the square. So it's going to be half of the 4, which is 2, and put it in parentheses squared. So half of negative 4 was 2 in parentheses squared. And we have technically added a 4 to this side of the equation. So what I should do is add a 4 to this side of the equation. That 2 squared, I added a 2 squared. I need to add a 2 squared over here as well. From here, now I have a y pretty much by itself. I can actually solve for y, which would be 4 plus x equals y minus 2 squared plus 1. Move the 1 over, and that would make it a 3 because we'd have to subtract 1 from both sides, and we'd have y minus 2 squared. And we're almost done. Square root both sides. We'd have the square root of 3 plus x equals y minus 2. And add the 2 to the other side. So it'd be 2 plus the square root of 3 plus x. That is not the way I have seen a lot of them, but you could also write that as y would equal the square root of 3 plus x plus 2. Like I've seen it that way. And I've also seen it as x plus 3, because those are also the same as well. So all of those are correct. Do not forget where you have 1, you could have the other one, which would be the negative version of it, but not negative on the 2. That 2 stays as a plus 2. Okay? So that's with completing the square. Completing the square I think is a little bit easier. You could do negative b over 2a to get the same effect. So if we did negative 4 over 2 times 1, you'd end up with 4 over 2, which is 2. And then if we were to take that 2 and plug it back in, we'd have 2 squared minus 4 times 2 plus 1, which would be 4 minus 8 plus 1, which is negative 4 plus 1 is negative 3. And if we were to write our equation, it'd be x y minus 2 squared minus 3, which looks very, very familiar to the other things we just had, because if we were to solve for that one, you would have to add 3 over x plus 3, y minus 2 squared, and when you square root it, you get the exact same scenario where we have the square root of the x and the 3, and then the 2 that we would have to add to the other side. It's more of a matter of how to put it into vertex form. And putting it into vertex form is needed to find the inverse of anything like this. Okay? So that's going to do it for this one. I hope you're having a great day. I will see y'all on the next one. Bye.